passwords are the key to our digital security, but what if those keys were easily cracked? If you've ever been curious about how password cracking works, well then you're in the right place, because in this video I will show you how John the Ripper can be used to crack a wide range of password hashes, exposing just how easily some passwords can be compromised. Now, John the Ripper, or just John, is a free and open source tool for cracking passwords, and it's mainly used to test password strength or recover forgotten ones by cracking their hash values. And a hash is what you get when a password goes into a cryptographic function and turns into a fixed length string. Before we actually start cracking anything, the first thing you need to do is to figure out what type of hash you're dealing with. This is important because different hashes require different cracking techniques, and fortunately for us, John can automatically help with this. But sometimes you will still need to do a little work to identify these hash types. You can generally identify the hash type by looking at its length, structure, or any potential prefixes or salts. And even though some hash types are easy to recognize, sometimes hashes might look more complex or not easily recognizable. And while John can often recognize the hash type automatically, it's still a good idea to identify it first, because at the very least it will speed up the cracking process. Now, to do this, you can use tools like hash ID, which is basically a command line tool that helps identify various hash types. All you would have to do is to paste the hash value after the command, and then it would list the potential hash types. Alright, now let's talk about actually cracking those password hashes. The first mode we're gonna use is the wordlist mode. This mode is the default, and John basically uses a word list, which is just a list of potential passwords, to check if any of those words in the file match the hash we're trying to crack. This is the most efficient method, especially if you have a really good word list. So let's use this mode in an example. And even though I'll focus on MD5 hashes in this example, the process is going to be pretty much the same for other hash types. First, you need to have your hash stored in a file. And for this example, I already have a file called my hashes, and it contains some usernames. This file basically represents usernames and passwords, but we just need to crack the password hashes first. Since we are working with MD5 hashes here, we'll need to tell John which format to use. And you can do this with the format option followed by the format identifier for that specific hash. And for MD5, the format is going to be raw-MD5. But if you're ever unsure what formats are supported, you can always use the list option to check what formats John can crack. Now, to crack the MD5 hashes using the RockQ word list, assuming that you already have this word list on your system, the command will look like this. Format equals raw MD5 will tell John that you're dealing with MD5 hashes here. Word list equals RockQ will tell John to use RockQ as the word list, and max length equals 10 will basically limit the cracking attempt to passwords of 10 characters or less. And finally, my hashes is the file where the hashes are stored. When you run this command, John will go through the RockQ word list, which has millions of words in it, and try each of those words as a possible password. And if any word in the word list matches the hash, meaning that they produce the same hash value, then it will have found the correct password and then display it on the screen. Alright, now let's take a look at single crack mode. Now, this mode is different from the word list mode because it's designed for cracking passwords that are likely based on user-specific information like their names or usernames. In this mode, John applies mangling rules to the username or any other identifiers to generate possible passwords. For example, let's say we have a username called Alice, and John would apply different variations to this name by changing letter cases, adding numbers, or appending common suffixes like Alice123 or Alice2025. These variations combined with user-specific information can help crack passwords that are simple or commonly based on a user's identity. To use a single crack mode with John, you don't really need to specify a word list because John will automatically generate potential passwords based on the data in the hash file. For example, if you have a file that contains the password hash for the user Alice, then you can run single crack mode with this example command here. The single option will tell John to use single crack mode, which will apply mangling rules to the usernames and other information in the file, and the minimum length will make sure John doesn't generate passwords shorter than 6 characters, and my hashes is basically the file where the hash is stored. When you run this command, John will take the username, which is Alice in this case, and apply variations like changing the case, adding numbers, or adding other common patterns. Using this mode is going to be fast because it focuses on these simple variations of the username or other identifiers in your hash files. But if the password is complex or doesn't really follow any typical patterns, then this mode will not work as well as a wordlist mode. The more information you have, the easier it will be to crack the hashes using the single crack mode. Alright, now let's talk about incremental mode, which is the most comprehensive but also the slowest mode. In this mode, John doesn't use a word list like in wordlist mode or apply simple variations like in single crack mode. Instead, it brute forces passwords by trying every possible combination of characters until it finds a match. Incremental mode is great for cracking strong passwords, especially those that are random or not easily guessable. It will start with the simple combinations like A, B, C, and then continue generating and trying every possible combination of characters. And obviously, the more characters in the password, the longer it will take to crack. You can run incremental mode with John by simply using the incremental option. And if you know the password policy, you can even limit the search using the minimum length and the maximum length options. So for example, here the incremental option tells John to use the brute force mode. Format basically specifies the hash type we're cracking. My hashes is the input file, which contains the hashes you want to crack. Minimum length limits the passwords to at least 4 characters long, and maximum length basically sets the maximum length of the passwords to 10 characters so John won't go beyond that. When you run this command, John will start with simple characters and gradually increase the complexity by adding more characters and eventually covering all possible combinations. Even if you're working with a very strong password like a completely random string of letters or numbers and symbols, this method will eventually find the correct password, but it may take a significant amount of time or resources. You can do a lot of cool stuff with John, and one of them is cracking actual system password hashes. For example, on a Linux system, password hashes are stored in the etc shadow file, while the user details like usernames or user IDs are kept in the etc password. John needs information from both of these files to crack those hashes properly because it uses password data to match the hashes to actual usernames. So oftentimes we just combine them into a single file using a built-in tool called unshadow. This tool basically merges the contents of both files into a format that John can understand. And to combine them, we simply use the unshadow command followed by the password file and the shadow file. And then we redirect the combined content into a new file. This will create a single file called myhashes, which contains all the necessary data in the right format. You can then run John by specifying the hash type to crack those hashes. And if you're successful, John will display the cracked passwords on the screen. Additionally, we can also crack Windows password hashes, but Windows password hashes are going to be stored differently, which is usually going to be in the SAM database. And the hash format most commonly used in Windows is going to be NTLM hashes. Once you got your hands on the dumped NTLM hashes, you can then save them into a file and then crack them with John by basically specifying its hash type as NTLM. For example, here the format equals NT tells John that you're dealing with NTLM hashes, and it will simply use the RockU word list to crack the hashes inside the file. Again, if you're successful, John will display the cracked password on the screen. So that's a quick look at how John the Ripper works and how powerful it can be for cracking different types of password hashes. Now you've seen how password cracking really works and how weak passwords can fall apart when tested with the right tools. It just shows how important it is to take password strength seriously, especially when something as simple as a word list can break through so many of them. If you found this video useful, don't forget to like, comment, and subscribe. And as always, thanks for watching, and I'll see you in the next one.